All right, recording in progress is good. All right, so we're here. We're reviewing for the test tomorrow. So I'll do some of my own problems, but if anybody has their own questions that they want to bring up, you can bring that up also. So reminders for the test tomorrow. So as soon as class is over, you may start submitting the homework if you wish. But otherwise, the latest you can submit it is half an hour after the test ends. So that would be what? Test ends at 10 o'clock. So you have until 10:05 tomorrow a.m. to submit the exam and until 10:30 to submit the homework. But you can submit it after class or tonight. That'd be fine also. This is what you have to turn in. You must submit at least 70%, but that's easy to do since I've done quite a few. Excuse me. And let's see, what else? You get to have a cheat sheet, one formula sheet like this, 8.5 by 11, both sides. Put anything you want. And a calculator, but nothing else. No other books, notes, people, computers, internet, so on. Okay. About 10 questions. So it looks like 2 from each section, maybe a couple from others. Okay. Have your camera on, true background, and keep yourself muted. If you have any questions during the test, just send it in the chat. All right, so that's the way that goes. So any quick questions now before I get started with the review? Now that you've already seen one test, you know the way they all work pretty much the same way. Okay, here we go. And some of these questions I've actually already done before, but that's okay. I don't mind doing them again if somebody has a question about them. See 2.3, number 3. Go back to this. All right. So you got a request for 2.5, 31, and 35. Let me see if they're on my docket. I do have 35, I think. If not, ask me again, please. Okay, so here's f of x, here's g of x, 2.3, number 3. So the sum is just like this. And to get a common denominator, here's x minus 2, multiply this by x minus 2 over x minus 2, multiply this side by x. So it gives me x minus 2 plus x squared over x times x minus 2, or x squared plus x minus 2 over x times x minus 2. Then ask for the domain. Domain is all real numbers minus a set consisting of 0 and 2. F times g, well, if you multiply these, notice the x's cancel out. You have 1 over x minus 2. But the domain is still all real numbers minus a set consisting of 0 and 2, because you have to write down f, right? And even at this stage, 0 is not allowed, f times g. So officially, this is the function. But it's all real numbers minus a set consisting of 0 and 2. F divided by g, 1 over x divided by x over x minus 2. Same thing, x cannot be 0, x cannot be 2. And let's see, if you divide by a fraction, you multiply by the reciprocal, 1 over x times x minus 2 over x. So x minus 2 over x squared. But again, the domain is all real numbers except for 0 and 2. 2.417, h of x is cube root of x minus 4. The outer function is the cube root. That's my f of x. And the inner function is just x minus 4. And therefore, f of g of x is f of x minus 4, which is cube root of x minus 4. Okay, quick reminder about the opposite of a function, the negative of a function. And easy way for me to remember is, you know what x squared looks like. And what does negative x squared looks like? Well, all the positive numbers become negative, so it will just be a reflection across the x-axis. Here's g of x is negative x squared. Okay, so that means negative f of x, that's a negative, not a, marker. Negative f of x is the reflection of f of x across the x axis. So if you have the negative of a function, you reflect like so. Okay, 2.535 is asked for. F of x equals x squared plus 1 for x greater than or equal to 0. I'm not looking at the right thing here. Anyway. Okay, so y equals x squared plus 1. Switch around x and y. X equals y squared plus 1. Solve for y. Subtract 1. Take the square root. So y equals f inverse of x is equal to radical x minus 1. Okay, so x squared plus 1 looks like this. And square root of x minus 1 looks like this. And there's the reflection across the line y equals x. Okay, and I think we talked about this already. The domain here is 0 to infinity, and the range is 1 to infinity. So they flip for the inverse, right? So we have this over here now. Okay, let's see, getting some more here. 2.531, 2.311. See if I get around to those. 2.4 number 9 was asked for. Here's f of x, here's g of x. What is f circle g? So f of g of x, fog, f of x squared plus 2x is 1 over x squared plus 2x, or 1 over x times x plus 2. So the domain is all real numbers minus a set consisting of 0 and negative 2. Okay. The other way around, golf, g circle f, g of f of x. That means I'm doing g of 1 over x. And now that goes right there and right there. So it's 1 over x squared plus 2 times 1 over x. That's 1 over x squared plus 2 over x. Multiply top and bottom by x to get a common denominator. So 1 plus 2x over x squared. Domain is all real numbers minus a set consisting of 0. Okay, 2.413 was asked for. F of x, g of x. Okay, I think we've looked at this before. F of g of x. Well, g of x is 1 over x plus 1. F takes the reciprocal of this. So I want the reciprocal of 1 over x plus 1. In other words, 1 over x plus 1. And if I divide by a fraction and multiply by the reciprocal, so just x plus 1. The domain is all real numbers except for negative 1. You can't get past the negative 1 here. So that would that one. G of f of x, g of 1 over x. So 0 is not allowed here for sure. And then whatever's behind my pen goes right there. So it's 1 over pen plus 1. So 1 over x plus 1. Again, 0 is not allowed. And get a common denominator, multiply top and bottom by x over x. So x over 1 plus x. And from here, negative 1 is not allowed. So my domain is all real numbers minus a set consisting of 0 and negative 1. Okay, let's see, 2.529. We had already talked about that, I think, but f of x equals 1 over 2x is half times 1 over x. Find the inverse. Let's call it y. Y equals 1 over 2x. Switch around the x and a y. Put x here, put 1 here. So to find the inverse, we switch around x and y. X equals 1 over 2y. Multiply both sides by 2y. 2xy equals 1. Divide by 2x. So y equals f inverse of x is 1 over 2x. And yes, it happens to be the same as the original. Okay. So when you graph f, you've already graphed f inverse. They are the same. And they are the reflections of each other across the line. Y equals 1 over x. The reflection of this is this. The reflection of this is this. Okay, let's see, 2.415. Write it as a composition. H of x is 3x squared minus 2 to the 4th power. So the outside function is raising to the 4th power. So that's my f of x, x to the 4th. G of x is the inside thing, 3x squared minus 2. Okay. See, 2.321, that's what's the difference between x squared minus 4 over x minus 2 and x plus 2. Let me go back and show you that problem. Yeah, 2.3, yes, it's 2.3, that's right. It says 2.4 there, but we're still finishing up 2.3. 21. What's the difference between x squared minus 4 over x minus 2 and x plus 2? If you do the algebra, it looks like they cancel each other out. Okay, but f of 2 does not exist. DNE means does not exist. You'll be using DNE quite a bit in calculus, so I'm getting used to that. DNE does not exist, but G of 2 does exist. Okay. And in algebra, we're actually quite sloppy when we say that this is equal to this. That's actually not 100% true. It's true for everything except for x equals 2, because x equals 2 is allowed here, right? But x equals 2 is not allowed here. So that's a major difference there. Okay, 2.531, and I think somebody asked for that, so here we go. F of x equals square root of 1 over radical x. So call this y. Y equals 1 over radical x multiplied by radical, switch around x and y, that's right. X equals 1 over radical y. Multiply both sides by radical y. So x radical y equals 1. Divide by x. Radical y equals 1 over x and square both sides. So the inverse function is 1 over x squared. So they look kind of similar. Okay, but this is what they would look like. So they both go through 1, 1. Okay, and then over here I had 4 comma 1/2, which means over half you would have 1/4 comma 2, and so on. And so it ends up looking something like that. And it's kind of hard to see the reflection, but that ends up reflecting there. That ends up reflecting there. And so that's that one. 2.533. And let me check the chat. Okay, 2.533. I'm already doing now. 2.531 was also asked for originally. So here's 31. 2.533. F of x equals 1 plus x cubed. Okay, so call it y. Switch around x and y. X equals 1 plus y cubed. Solve for y. So subtract 1, take the cube root. So y equals f inverse of x equals cube root of x minus 1. Okay, x cubed. Now you should be somewhat familiar, I think, with x cubed. X cubed generally looks something like that. Okay, cube root looks something like that. So let's see, x cubed plus 1, shove this one up. This one Well, take that graph and move it 1 to the right. Okay, so that means here's F, and here would be my F inverse. Okay, if I try to do my reflection property right, looks like it would be something like that. Okay, and let's see. Yeah, let me get these out of the way. So what was the idea behind 2.217? Right. In the interest of time, I'm not going to graph it. Now, you might have to graph these in the test, but I'll just talk about what happens to them. Okay, so you'll just have to write it or listen to the recording later. So A, that goes 2 units up. This one is 2 down. This is 2 left, 2 right. I know, I can maybe just write it like this. Let's see. 2 up, 2 down, 2 left, 2 right. That's what it says it. Right? 2 up, 2 down, 2 left, 2 right. 3x cubed. Okay. That kind of scrunches it in. Okay, so it's a vertical stretch. Okay. So vertical stretch. Okay. So it's going to shoot up faster and shoot down. And the negative reflects across the x-axis, right? I can squeeze that and reflect. Answer to E across x-axis. Okay, so that's that one. 2.225, x squared minus 6x plus 7. I know it's a parabola which opens up. Find the zeros, quadratic formula. 2.225, so x is negative b plus or minus the square root of b squared, 36, minus 4 times a times c over 2a. 36 minus 28 is 8. So it's 6 plus or minus radical 8 divided by 2. 8 is 4 times 2, and I can write it as 2 radical 2 divided by 2. So 3 plus or minus radical 2. Radical 2 is about 1.4, so it's roughly 1.6 and 4.4. Okay, so for the graph, it's crudely something like this. So here's the original f. And for absolute value of f, anything that's below the x-axis, the U shape, reflect here to the upside down U shape. Anything that's above stays the same. So that stays the same. That stays the same. Okay. See, 22. F of x is negative parentheses x minus 1 squared plus 1. So there I start with my negative x squared and then shift 1 to the right and 1 up. So I take this shape and then go like so. So that's f. And once again, for absolute value of f, anything that's already above the x-axis, that part stays as, whoops. This thing lets it go change focus on me for no reason. Okay, so that part's above the x-axis stays the same. And the part that's below the x-axis, these two guys here, reflect above the x-axis. So it goes like that and that. So again, I get this funny looking W right over here. Okay, 2.411. Let me check the chat for anything else. 2.2. 2.215 and 19 are asked for. Okay, let me see if I have time for that. I think I'll be okay with that. Okay, 2.411. So fog and Goff. So fog, f of g of x. So f of x squared minus 3, which is radical x squared minus 3 minus 1, square root of x squared minus 4. Okay, and I think we did this before. Ask me if you're not sure, but you do the same breakdown for the domain. X squared minus 4 is greater than or equal to 0, and you do the number line stuff, right? And we got to do all this stuff. It ends up being negative infinity to negative 2 bracket union bracket 2 to infinity. Goff, g circle f, g of f of x is g of radical x minus 1. So right here, x has to be greater than or equal to 1. Even though the final result seems to indicate that you can have anything, because if you plug that in, now for g squares whatever you give it and subtracts 3. So radical x minus 1 squared minus 3. Well, if you have a square root and you square it, you just get x minus 1 minus 3, x minus 4. Nevertheless, the domain is still going to be bracket 1 comma infinity. Because you're not allowed to plug in 0 right here, let's say. Okay. All right, so I think that takes care of those that were previously asked for. Now for today's list, 2.531. I don't think I got to that one yet, so let me see. Oh, 2.531. Did I do this one? Not sure if I did this one. 1 over radical x. I don't mind doing it again anyway. One over radical x. Well, just a quickie table. 1 gives me 1. 4 gives me 1/2. 1/4 gives me 2. Okay, so that's just all I'm going to do for now. One, 1, 4, 1/2. 1/4, 2. And now find the inverse. So y equals 1 over radical x. Switch around x and y. X equals 1 over radical y. Multiplied by radical y. X radical y equals 1. Divide by x. Radical y equals 1 over x. Square both sides. I think we did this one anyway. Y equals 1 over x squared. It ends up being somewhat close, but anyway, so 1/2 comma 4 is like this. 1/2, 4, and 1/4 comma 2 becomes 2 comma 1/4, which is lower here. So F inverse ends up looking something like that. Yes, for 31. Okay, let me show you the work there. Get this back in focus. There we go. Okay, let's see. 2.3. 21, I think was asked for. Check. Okay, 2.321, we already talked about that. Okay, so that's it for that one. 2.2, 15, and 19. Okay, let's see what that is. Okay, 2.2, 15. I think I decided to skip that one if I'm not mistaken. Yeah, 2.2, skip 15. I botched that one up. And 2.2, 19. Okay, 2.2, 19. All right. And if I'm not mistaken, I think that's the last one I saw in the chat. I have to stop the share temporarily, double check the chat. 15, 19. Sometimes it's hard for me to catch up with everything. 2.2, 19. Okay, I think I've caught up after this, but it's hard for me to lecture and teach and read everything in the chat at the same time. So if I missed your question, please ask it again. Otherwise, I'm done after this one problem. We'll just end early if anybody else doesn't have anything. Okay, so go ahead and ask again. I'm trying to read through the chat, but it's hard to think about what was done and what wasn't done while lecturing at the same time. So graph this in absolute value also. Okay, so we know that looks like y equals mx plus b. So 0, -3. Slope is 2, 2 over 1. So over 1 up 2, over 1 up 2, over 1 up 2, and so on. Here's f. And then for f inverse, I'll use green, I guess. This part above the x-axis, n0, stays the same. This part, which is below, reflect across the x-axis. Something like that. So the green is f, absolute value. Whoops, absolute value. And as we anticipate, right, absolute values are going to be somewhat V-shaped, as you would suspect it to be. Okay. All right, I see something new in the chat, so let me check that. Okay, 2.311. Again, I think I've caught up, but if I'm wrong, again, if I missed your question in the chat, just please put it back in the chat. It's almost like I need somebody just to keep track of what I've done here, because it's hard for me to keep track of checking off, oh yeah, I did this, I did not do this, and so forth. Okay, so feel free to put it again. If you put something in the chat and I missed your question, just ask again. I think that's probably the most efficient way for me to do this. 2.3, number 11. Okay. G of x equals absolute value of x. And they want the graph of the reciprocal function. Okay. So how about f of x equals 1 over absolute x? How does that work? Okay. So use my principles of reciprocal. Try to get this thing back in focus. There we go. Okay, absolute value of x, you should be familiar. Whoops. Off beat there. Should be like that. Sorry. Okay. All right, so what are the principles for reciprocal? Okay, you want to find out 0, 1, and -1. Well, there is no -1 here. Okay, why do I want 0? If the function is 0, its reciprocal is undefined, so no graph is 0. You can't do 1 over 0. And then we said 1 and -1 stay the same because the reciprocal of 1 is 1. So they agree here and here. And then when 1 goes up, the other goes down. 1 increases, the other decreases. So let's see, this side increases, this will decrease. If I go from right to left, here I decrease, so here I increase. And over here, going from here to the origin, I decrease. On this side, I increase. And if I go from right to left, here I increase. This must increase, so this must decrease. So there is f, 1 over absolute value of x. All right. Okay, we still have 15 or more minutes. I think I've caught up with the chat. We start to share. If anybody else wants to ask anything, you may. Again, if I miss you, just put it again because it's hard for me to read through all the questions there. So go ahead and ask again. So anybody else with a question, please? Otherwise, we're done for the day. And you will, while I keep blabbing, giving you more time to type something in the chat. So as soon as I finish today, you can start turning into homework. Just like last time, take pictures on your cell phone of your homework, click, 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 click. It may not all fit in one email or one file, so you might have to break it into several. That's okay, I don't mind that. The latest you can turn it in is half an hour after the test, right? So tomorrow, right around what, 9 o'clock, so 9:01, 9:02, I'll send the exam on Canvas announcements. Then you join the Zoom session, have your camera on with a true background. Keep yourself muted. If you have any questions, put them in the chat. I will close the Zoom class at 10. So you have until 10:05 to click, 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 or scan. And you have until 10:30 to submit the homework. Although I'll take the homework, as soon as we end class now. And then that's pretty much it. You can have your one cheat sheet. So any rules, any formulas, sample problems, one sheet of paper, that's okay by me. And that will be all right. Okay. All right, I do see now 2.5 number 1. So let me go ahead with that. .5 number 1 is just simply, is it 1-to-1 or is it not 1-to-1? Okay, so this does appear to be 1-to-1. It would pass the horizontal line test. And yeah, write something like that on the test. So if I say, is this a function? Yes or no. Don't just tell me yes or no. Say, because it passes, it does not pass the vertical line test, horizontal line test, or whatnot. Okay, so give an explanation. So 2.5 number 1, it is 1-to-1. It is a 1-to-1 function. Okay, and let me check the chat again. Okay, again, I think I've caught up. So anything else, please? Wait just a moment. And otherwise, I'll see you tomorrow for the test. Okay, I see nothing and I hear nothing else. So I'm assuming that's it. All right, folks, have a good day. You can start turning the homework and see you tomorrow for the test. All right, bye, everybody. Have a good day. Thank you. Bye.